Well, good morning, everybody. Welcome. It's 10 a.m., so we'll go ahead and get started. Thank you for joining us today. Hope everybody is well. Today, we are joined by Condair, Nick Wilson, who is our regional sales manager, and Quentin Ashby, who is an applications engineer with Condair, and we'll be discussing humidification. So I'll turn it over to them, and thank you, everybody, for being here.
Okay, so hello and welcome everyone. Thanks for hosting us. My name is Nicholas Wilson. So as Luis said, I'm the new regional sales managers for West Region. So I cover everything essentially from Colorado to Hawaii, all those states. I'm joined today by my colleague Quentin Ashby. He's one of the heroes in our applications department. So his primary focuses are on isothermal and dehumidification within it. So quickly for today, we have a lot to cover, but I'm going to do a quick portfolio overview of how everything looks today. And then what we found is that we've done a lot of these sales overviews in the past, but we wanted to get more granular on some installation and design kind of quirks that we've seen that might cause some issues down the line through its supply chain. So we've tasked Quentin essentially with putting an hours-long presentation into around 15 minutes, so good luck to him. So to quickly jump in here, our isothermal humidification portfolio, not too much looks changed here. It's our robust, kind of the cornerstone for how we base our business around. Just to quickly cover, steam's produced from a various different forms, so electricity, gas, or from an existing boiler system. Last year for the West region, about 75% of our sales came from isothermal. Quentin will touch on this as well, but one thing to consider here is it depends by application, but typically it's a lower upfront cost, but higher variable costs as you go along. For adiabatic, not too much to cover here. So we have our standard ducted and direct applications for in-room solutions. Two products that I wanted to note, and again, we can book follow-ups if you wanted to cover it further. So we just launched this JS60C. It's a jet spray for compressed air in space solution. And then our new mobile humidification option is now available as well. It's a ultrasonic in-space humidifier. It's kind of an all-in-one IEQ solution. So it has air filtration and a UV system built in there as well. So any questions there, we can follow up in the future. And then for desiccant, it's a nice option to have as well for mixed use spaces. So if you want to add humidity into one section with some adiabatic technology, and then dehumidify the space in another zone. So it gives you some flexibility there in the design. With that being said, I'm going to quickly pass this over to Quentin to kind of go through the rest of the presentation.
Okay, hi everyone. I'll try to make a good time today, but we got a lot to cover. So kind of just going over the product portfolio again. A lot of questions that we do get are, okay, I have an application. What technology should I look at first? What should I lean to? So here are 4 things that we kind of see as the first steps for getting a better understanding of the application. So the first thing is, where will this humidifier be installed / where will the moisture be distributed? So if you look, we have 2 different ones. We have, is it in duct? So is it in an air handling unit or some ductwork, or is it in the space itself? So if you look at the 2 types of humidifiers, there is some differences. The isothermals, they are very modular, and we can use them in a lot of different scenarios. You can see that we can use them both in duct and in space for most of them. There's an exception with the live steam, so that's direct boiler injected steam. We can't use that in space, but overall, they're a very flexible option. On the other side, with adiabatic systems, we do have to be a little bit more careful, and we have to know exactly where it's going to go into. If we look at our ME, which is wetted media, or our high pressure or DL, so these are atomized systems, these are only in duct. So important to note, if you're looking at these, or if you know you have an induct, these are good to go. On the other side, we do have direct room systems. So MLDRS, so atomizing in space, and then a new jet spray system. So a little bit more specialized for the specific application, but then again, adiabatic does cover the full range. Another thing that we would want to look at too is the size of the system. That's a good first step if you're looking at a new job. And we think around 200 to 250 pounds is kind of the turning point for whether you're going to choose isothermal or adiabatic. So if we look at if, at least for our product line, if a 200-pound or greater unit is available, if we look at electric systems, we don't offer more than 200 pounds per unit. We can combine multiple units, but at that point, the electricity needed to generate the steam can start to add up fairly quickly. So we'd want to go with more a gas system, which is usually fairly efficient, or direct boiler steam, which is very efficient because it's already on site. But say we're going past that 250 and we're much higher, almost all of our adiabatic systems do cover that high range except for the jet spray. And this is when you would really want to start to look at an adiabatic solution more than isothermal. The cost savings alone can start to add up very quickly. If you're looking at, say, 1,000 pounds per space, 2,000, it makes no sense to really be using electric humidification in that case. You still can use gas, and you still can use some of the other systems, but they might not be as efficient as a adiabatic, which can actually start to pay off itself. As Nick said, the initial cost is usually a little bit higher on the adiabatic systems compared to the isothermal, but we can do an energy analysis. We can actually look at utility rates and see if it would make sense for your application or not. Finally, one last thing to consider is that not all water is created equal. If we look at what water treatment, almost all of our systems can be used with potable water and don't require any water treatment, except for 3 of our adiabatic systems. So the DL, the HP, and the ML, so these are all atomizing systems. No matter what, they will need some form of water treatment, and that's just because of the nature of how the moisture is being released. I'll get into that in the next slide a little bit, though. So just kind of covering water treatment in general, we do have a water treatment guide available on our website, but as I said before, not all water is created equal. Certain units do have certain requirements for water. As you can see, the EL, which is a regular canister system, it has to use potable water because it relies on minerals to actually conduct that electricity, compared to the RS, which can use any type of water. It doesn't matter, it's using resistive. On the same side, there are specific requirements for adiabatic, so we need RO or potable, depending on it. That's all laid out. In terms of why we would use the water treatment systems, if we don't need to, for isothermal, there actually is no hygiene incentive. You're boiling the water, so there's no risk. Essentially, it's just for prolonged efficiency and maintenance requirements. So if you want to reduce maintenance, you can treat that water. A little bit different for adiabatic. So it does increase operational performance and reduces dusting. So that's the minerals in the space itself, and reduces maintenance. At the same time, since we are using cold water, we want to make sure that we're removing all bacteria. So we do have other hygiene components in there as well, but we want to make sure we're cleaning it well. And I'm running slow, so we'll get going. So for today, we kind of just wanted to cover some best design practices because we see a lot of issues in the field of people not fully understanding atmospheric systems. So a lot of people seem to think that atmospheric steam lines are the same as pressurized. They actually have a completely separate rules for how we install them. So just some general guidelines is we always want to follow recommended materials, size, and length. So we have those out in our installation manuals, and those should always be followed. Otherwise, there can be some issues in terms of like back pressure to the units, which can cause faults. For number 2, we always want to make sure that we're insulating the pipes itself. So as this is atmospheric steam, if there's a lot of conductivity and a lot of heat transfer within the pipe, we can actually start to lose it to condensate, which I'll go over in a little bit. So we always want to make sure we're insulating. 3, steam lines always have to be sloped. So we're getting rid of the condensate via gravity. So if you have a flat line, that can actually start to impede the steam itself. So we want to be really careful when we're installing steam lines that they're always sloped, and we want to consider that when we're looking at possible installation requirements. Finally, all of the condensate does need to be trapped. So again, we do have all these requirements set out, but it's good to look at these before the start of the job to make sure that we can meet the requirements. Kind of having a little example here. So if we look at, this is an EL steam line maximum equivalent length chart. So as you can see, as the model goes higher, so the higher pounds per hour, we can actually go longer with the steam line. One thing to note that this is a maximum equivalent length. So equivalent length is actually taken into account back pressure from elbows and fittings into that length. So it's different than the linear length. So that's something that we need to consider. If you have a long or even a short length, but a lot of fittings, its equivalent length might be longer, and we do need to watch out for this. So again, this is good to look at the beginning of a project to see if the installation requirements can be met. Going forward quickly, again, touching on condensate losses. So this is really important. So there are two sources of condensate losses. There are steam line losses. So this is based on the steam line diameter and the length. So if you have a bigger, longer steam line, you're going to get more condensate. At the same time, there's also from distributor, so where we're actually injecting the steam. These are all for in duct as well as in space as well sometimes. For distributor losses, this is based on duct conditions and the type of distributor used. So if you have a large distributor in an air handling unit and it's very cold in there, you're going to get more condensate. Why this is important is that if this needs to be considered in terms of sizing. If you have, say, a 200-pound requirement in the space and you choose a 200-pound unit, you should know that you won't be able to get 200 pounds exactly out of the unit. There will be losses no matter what. We can try to minimize them as much as possible, but typically you will have to oversize a certain amount to get the steam that you want. Some other quick considerations is that most local codes require drain water to be 140 or less. This typically requires a condensate water cooler. All of our own units have internal drain water cooling, but the condensate is a little bit different. Certain units can receive that condensate back to the humidifier. However, it's important to note that in scenarios with larger capacities, as well as our steam short absorption manifold, which is a fairly large manifold, it produces too much condensate and it has to be sent to drain. So important things to consider in terms of condensate. Going forward, I'll touch upon this just a tiny bit. So in terms of locations of what we want to see, supply air is a very good location. There needs to be sufficient straight duct for absorption. And we do have to be wary about velocity, which I'll touch on, but it's a good spot. Next best spot is between the heating and the cooling coil. That's a great spot for a humidifier. There's warm air, which really helps decrease the absorption. But yeah, we do have to make sure that there is enough distance between those two. The other locations, 3 and 4 are okay, not the best. And then 5 and 6. So anytime where we're mixing cold air, not a good place to put a humidifier. It just introduces a lot of complexity and there could be a lot of issues. Kind of going forward on that same path. So there are things to consider in terms of velocity. So maximum duct velocities do vary between technology. So for isothermal, we typically say it's around 250 to 1500 feet per minute. And then for adiabatic, it does vary on the technology, but again, around 109 to 884. So something to consider, you can't just put a humidifier in no matter what. We have to make sure that it's meeting the requirements. Otherwise, there can be some issues. On the other side, in terms of placement, we want to make sure that we're placing humidifiers correctly in terms of any obstructions or elbows. So if we are upstream from an elbow, we want to make sure we're at least giving the absorption distance, maybe a little bit of a safety factor as well. And then if we're downstream from an elbow, we want to make sure we're at least around 6 feet. So this is very safe, but we want to make sure that there's laminar flow, and typically that's as far as possible from the bend as possible. Going forward, kind of changing directions a little bit, going over, we're almost out of time, going to controls. So there's 2 different types of controls. We have safety devices and control room devices. Important to note that air-proofing devices and high-limit humidistats in the duct are necessary. And then I'll go over the other types. 2 types of controls. We have on-off or modulating. We highly recommend modulating as it can actually increase the accuracy of the humidification. And then in terms of modulating, we have a humidistat, so modulating humidistat versus a sensor and transducer. Only difference there is where the logic is being applied. The humidistat applies the logic at the stat itself, and then the sensor sends a signal to the humidifier, which then does the logic. Kind of at the end of this now, some common issues that we see in the field that we kind of want to get across are, one of them is mismatched. So this is our SAME, so it's a distribution manifold. This does hold true for all manifolds. Anytime there's a mismatched inlet, so say you have a 3-inch line and you're reducing it to a 1/2-inch inlet, that's going to increase a lot of back pressure to the unit itself, and it's not really viable. So we want to make sure that if we're pairing a humidifier to a distributor in a air handling unit, we want to make sure that they're the same size and that they are paired together properly. I touched on this a little bit, but incompatible water quality, we want to make sure that we're looking at the water quality before we size and select the units, and then definitely before we install them. So very important. Same thing, steam line lengths. We want to make sure that we're looking at it. You may actually have to upsize the humidifier to get the steam line length that you want. You could talk to your long representatives about what that would mean and how it would affect performance, but typically there's ways to mitigate, but definitely something that we do want to look at. And then finally, improper duct and air handling unit placement. So the placement does matter. It will affect performance, and we want to make sure that we're doing it in the most optimal way possible. Finally, so those were just some general rules, mainly covering isothermal installations. We do have a lot more best practices that we have internally. So adiabatic load sizing, modulating high limits is a big one, retrofitting, using multiple SAMEs or distributors in ducts. If you have any questions on any of these, please reach out to a long representative and they can definitely help you out. But yeah, there's a lot more that we can go into. We could spend a whole day on all of the best practices. But I think that's the end of today. If anyone has any questions, feel free to reach out to Long or to Condair as well. Thanks.
Yes, thank you. Thank you very much, both Quentin and Nick, for joining us today, and then everybody online. We appreciate it. So a lot of good information. Sorry, we're a little bit over on time. So now we get to the part that everybody's been waiting for. And if you could hit the next slide. And that part is to find out what our next coffee break is about. So next week we'll have Mike Toflius, and he'll be presenting on multi-stack solutions for electrification. So please be sure to tune in. Now we get to the part of the prize. This week's prizes, we have a choice of a $100 gift card to Sephora. So I'm sure a lot of you gentlemen could use that, or for the lovely lady in your life. The other one is a 6-pack beer holder, which I'm surprised is still available, but it is. Hopefully it disappears soon. And then the third one is Papado, $100 gift card to the Seafood Kitchen. And then if anybody is interested in having a lunch and learn on this topic, please reach out to your Long sales engineer. Thank you, everybody, for joining us. We'll see you next week.